strange thing called Postgres, and actually how does it compare to Oracle. And I put some slides together for this morning to kind of take you through this in the next 45 minutes. So without further ado, a little bit on the agenda that we have here this morning. So I want to do a very brief introduction of myself and perhaps the company that I represent. And I think there is some new stuff around that could be interesting. And then we're actually going to go in what is this thing called Postgres and how does it compare to Oracle, etc. So the really more cool stuff. And again, thank you for having me virtually in Slovenia today. I would have loved to be there physically, but unfortunately the circumstances prevent us from doing this. So who am I? I'm working in IT for a lot longer than I care to remember. I started working on Oracle version 6. That was very, very brief. Then I very quickly actually switched to Oracle 7. And I've been doing Postgres since version 9.6. And for some of you who may know a little bit about it, that is a couple of years ago. I started as a system administrator, database administrator, did some development and switched to the dark side of management and sales, but still very much with my feet in technology. I'm currently leading pre-sales for this company called Enterprise DB, and I'm a very fierce supporter of DBA Dev, trying to get developers and DBAs to actually work together instead of, you know, safeguarding their own house. If there are any questions at any point, please just interrupt me, we've got this cool raise hand function here, or just get Yuri to interrupt or something. Because the more interactive we can make it, the more you will get out of the presentation. I work for this company called EDB, Enterprise DB. Enterprise DB is the currently largest commercial entity behind Postgres. You could compare it a little bit like, you know, what Red Hat does for Linux, EDB does for Postgres. And we're based out of the US, Bedford near Boston, actually on the other side of the highway from Maynard. For those of you who may remember Digital Equipment Corporation, that was actually based in the old factory there. So that's actually very close. What is important, and which I will dwell on a little bit longer, is EDB's open source leadership. As you might know, and as I will go into that a little bit in the next slide, is Postgres is an open source product. It is not owned by anyone. It is, if you write something for Postgres and you commit code to Postgres, you actually commit it to the Postgres Global Development Group. But the Postgres Global Development Group isn't a physical entity. So actually, everybody owns Postgres and nobody owns Postgres. To be able to still get high quality products like Postgres is, out of that development, there is, as said, the Postgres Global Development Group, and that Postgres Global Development Group is led by the Postgres core team. Postgres core team exists of 2 to 5 people, and they basically govern everything that's happening within Postgres. As you may or may not have heard, EDB acquired a company called Second Quadrant. Together with Second Quadrant, EDB basically is the leading influencer within the Postgres Global Development Group. It is the rules of the group state that nobody can run the group in itself. So we are just the major influencer, meaning Postgres will always stay independent. There has been a little bit of discussion in the community if that's a good thing or a bad thing. Basically, it's a good thing because there are bigger players around Postgres, and we will get into that this afternoon as well a little bit. Bigger players around Postgres that want to kind of capitalize on Postgres, where we, as the Postgres group, just want to stay independent. So that's a very important step forward here. Major contributors, core team contributors, that is what the Postgres development group is made up of. And just as a spoiler alert already, if you have some time today or tomorrow, please go see momgen.us. Bruce Momgen is the founding core team member, and he writes very interesting blog posts, basically everything around Postgres from very deep technical to more organizational and structural around that. So very quickly about that. And when I want to do the comparison Oracle to Postgres, it all starts here. It's a very, very busy slide, but I will just say a couple of words to it. If you look at the green bit on the left side of the graph, you will find in the bottom it says System R. In the 70s, there were Date and Cott, Christopher Date and Ted Cott, who wrote relational database theory. Based on this relational database theory, a number of solutions were developed. So IBM DB2, Oracle, as well as Berkeley Ingress. Berkeley, the University of Berkeley in California started writing Ingress. Dr. Michael Stonebreaker created that at the university, took that to the market and actually found that there were ways to improve his solution. So basically he then came back to the university and started the post-Ingress project. The post-Ingress, well, the name already says it a little bit, became Postgres. So what is the key lesson we can learn from this graph? Basically is both Oracle, IBM DB2, and Postgres are based on relational database theory. If you start looking into the technology a little bit deeper, you will see that there are many of the internal workings of both databases or all of the databases that are actually the same. There are, in essence, 3 true relational databases in the world. That is IBM DB2, that is Oracle, that is what we're here for today, and that is Postgres, what we're going to compare to today. So that's basically the quick story with this graph. And then I just jump to my, it's what I like to call the barometer of what is actually happening in the landscape. It's a site called dbengines.com, and based on like 10 or 15 rankings, it filters out, okay, what are the most important things that are happening around databases. So what you will see is that both, if you look in top, the traditional databases like Oracle, MySQL, and Microsoft SQL Server are gradually declining a bit, but what is very, very apparent is that technology like Postgres is growing very, very fast. So this is a good indication that we were actually spending some good time here this morning, looking a little bit deeper into what actually Postgres is. So before we do the comparison, let's quickly look at what are some of the reasons why you would actually even be looking at some of this stuff, right? A lot of you are Oracle DBAs, I presume. It's a little bit hard to say, please raise your hands because I can't physically see you, but I'm just going to assume that, right? If you look at some of the reasons why you see the Postgres adoption happening in the world today, these are some of the 5 reasons that we see most. So cost savings, that is very simple. Vendor lock-in. So if you are actually working with a solution, and we just saw in the graph that Postgres is this independent technology, it is owned by nobody and by everybody. So that also means that if you want to just start downloading Postgres and start working with Postgres, you can do that. If you want to move in or move out, it's fairly easy. If something happens, you can even just go to the source code, right? You can read what's in the source code and figure out some of the more intricate things if you want to. It makes it easier to build multi-cloud, hybrid cloud strategies. This is what we see a lot today. Everybody is talking about cloud, and actually a lot of people are doing cloud. So it might make sense to be at least aware that there are platforms that allow you to build a hybrid cloud, so on-premise and in the cloud solution. The innovation that's continually happening, we've just released Postgres 13. And if you look at some of the developments that again go into a new version of Postgres, that really does not stop. And this is a little bit of a marketing point, I think myself. There is this thing like, you know, we want to do this digital transformation. Everybody's talking about that. One of the things that some of the benefits that Postgres enable is actually getting onto this digital transformation a lot easier. Well, this is why would you then choose EDB? So one of the core points of this presentation is also comparing Oracle to Postgres on the one hand. But what I will do in this presentation is actually focus a little bit more on a superset version of Postgres called Advanced Server. Advanced Server has a couple of expansions and extensions which enables the migration from Oracle to Postgres a lot more. So it helps you to do that migration easier. So that is what we're actually going to focus on, Oracle compatibility. If you now start looking at I have an Oracle database and I want to start looking to migrate that to Postgres. What are some of the objectives or some of the things that I'm going to run into? So basically one of the things is schemas. We all know our Oracle schemas with the code in it, with the tables, the data types, etc. We physically have to move that from Oracle to Postgres. Obviously, the data which is in that, how are we going to do that? Are we going to do a single step migration, or is there something more intricate that we have to start thinking of for our bosses? Like, is this an application that has low downtime requirements or something? How do we move that from one to the other and still do that with the least interruption? Something to at least consider. Infrastructure, we need to start building new execution environments. We're possibly running Oracle Exadata, we're running Oracle in Cloud, we're running other pieces of dedicated hardware or a specific deployment technology. We need to start build something that mimics that, but then running an Oracle database. So those are things to consider. And then finally, obviously, the application that is actually using the database that will speak a specific dialect of SQL. That dialect of SQL, that SQL dialect will have to be supported by the new database, by Postgres in this case. So if you then start looking to the practice, what are actually people saying, you know, if I start moving from Oracle to Postgres, what are some of my biggest obstacles? Well, the cost of the migration could be a thing, right? If you move from Oracle to Postgres, you would go to standard Postgres. There is a lot of things to consider, right? Data types, SQL language, there is no PL SQL support, etc. So consideration of cost in there is one. Migration of data definitions, stored procedures, connectivity. How do I actually get my application to connect to a Postgres database, to another database environment that is perhaps new to me or new to my organization or my environment, my experience, or even migrating data from Oracle to Postgres. Those are things that our customers, that people that actually use that, see as obstacles there. So another graph, there is something called the migration portal. Migration portal is a tool that helps very quickly assess if I want to move an Oracle database to Postgres, what are some of the steps I need to consider, some of the technology that we're going to look on in the second part of this presentation. How does that actually work for me? Things like DBMS scheduler, things like DBMS session, UTL, HTTP. How does that actually fit in the migration? If I move from Oracle to Postgres, this is something I need to think about because my application needs to run in the new environment and actually needs to have as little change as necessary, right? For that, we start bringing solutions. So we talked about moving from Oracle to Postgres. The standard version of Postgres is, in that sense, a little bit challenging because there is a lot of change required on some of the things that we're going to go into in what I said in the next phase of the presentation. We need to do it fairly fast. We need to have regulations. We need to ensure that we don't have to change the application too much. We have to ensure that the risk of actually the disruption risk for our application is reduced, and basically we need to start feeling at home in the new application as well. So those are some of the things to consider. So if we start looking into that, let's actually dive into the comparison between the technologies, right? Because it's good to see all of these obstacles that basically come across when you start considering, you know, I want to move to this open technology. I want to start doing some new stuff. And we've seen all these obstacles, and actually, you know, would I even want to start with that? Okay, well, let's see how we can kind of counter some of these things. And it all started out with an email I received earlier this year from somebody who said, you know, you guys with your Oracle to Postgres stuff, you don't have Oracle rack. There is no compression. There is not even advanced compression. There's no interval partitioning, no flashback, no distributed transactions. You guys don't do Apex. There are no transportable table spaces, no automatic storage management, no pipeline functions. How do you see this working? So one of the things that that you have to start thinking, that you have to start asking yourselves, what are you actually trying to achieve? What is your objective for the migration? What are your requirements? Do you have the guts to kind of step back, say, you know, am I an Oracle DBA or am I a database DBA? Well, a DBA basically, a relational database DBA. And is it something that, you know, I want to be able to put on my resume that I am a RAC expert, that I am an expert in managing Exadata? If that is the case, then, you know, most probably adopting new technology like Postgres is not really something for you, right? If you say though, you know, I want to add value to my organization, or I want to start playing with this cool new open source technology that brings me a lot of additional things, that's cool, because then, you know, this might just be the solution for you. And if we start looking at then comparing Postgres to Oracle, we see that, you know, besides a lot of differences between the two technologies, there are also a lot of similarities. So these are some of the things that we're going to dive into. And as you can see, there are quite a lot of different angles around a database that actually is something you want to start looking into. So without further ado, let's dive into the more interesting part, right? If you look at general capabilities, you will see that, and we saw that in the beginning of the presentation in the very busy Metro slide as well, both technologies are based on System R. that same steady relational database theory, the mathematical model that was created by Ted Cott. Both are object relational databases, both are ACID compliant and fully MVCC or transactional consistent databases, ensuring that you can do point-in-time recovery, that you can do transaction logging, etc. There is full transaction logging. In Oracle, it's obviously called redo log. On the Postgres side, it's called wall log or write-ahead logging. And both databases have a multi-tenant architecture. If you look at some of the terminology, so a table or an index in Oracle is called a table or an index. That's quite easy. In Postgres, they call that a relation. Okay, interesting. It's a mathematical thing. Cool. Let's just note it and forget it. A row is called a row in Oracle. It's called a tuple in Postgres. Okay. A column is called a column. In Postgres, it's called an attribute. And then it might make a little bit sense, right? Like if a column is part of a table, you might say an attribute is part of a relation. It kind of makes sense. A data block is called a data block in Oracle. It's called a page in Postgres when it's on disk. A page in Oracle is called a page, but it's then called a buffer in Postgres when it's in memory. Well, whatever. You know, read it once. If you go to the documents of Postgres, most of them will just speak of tables and indexes. Most will just speak of data blocks, etc. So this is just nice to know and then forget again. If you start looking at some of the other material like temporary tables, materialized views, constraints, they're basically the same between Oracle and Postgres, meaning that if you use a temporary table or a materialized view, you can use the exact same syntaxes in Oracle as well as in Postgres. If you start looking at in partitioning, so range, hash, list, subpartitioning, and IoT, not meaning obviously Internet of Things, but index organized tables, they are similar between Oracle and Postgres. If you look at interval partitioning or partitioned indexes, that is something that Postgres does not have. There have been ideas to create that, but it's never really happened so far. One of the things there is also, if you think something is missing in Postgres, it might be that it's not actually used that much, that nobody really took the energy to create it in Postgres. So that is one of the essential differences between a closed source and an open source solution in this. Looking at data types, we have Boolean. You saw the little note fall down. Integers, in Oracle it's called number. Postgres adds decimal, numeric, small integer, integer, binary integer. And if you look at all of these data types, you know, floating point, decimal, strings, Postgres has all of these and a bunch more. And you might think two things. One, does that really make sense? Because I've always been able to do in Oracle what I needed to do. You could say, well, it could be right. That doesn't really make sense. On the other hand, I have seen this a discussion between two application developers who are actually discussing which, excuse me, which data type they wanted to use for a specific issue. And at some point, if you're storing millions and millions of lines, and there is a data type that in specific cases can save you a bit, if that occurs often enough, those kind of bits start adding up, and you might actually save space by having a very specific data type. On the other hand, why would Postgres have all of these data types? A data type in Postgres is something you can define yourself. Postgres has what is called the Postgres extensibility system. Dr. Michael Stonebreaker, one of his most valuable lessons in Ingress was a situation where he had defined a data type in Ingress, where he thought, this is cool. This is something that makes my customers happy. And talking to his customer, the customer said, that's cool, but I don't really need the data type just like you defined it. I need it to work a little bit different. And that got him to think, I need a system where I can have user-defined entities. So Postgres allows you to write data types. It allows you to write operators. It allows you to write programming languages, obviously in order of increasing difficulty. But you were able, if you've got a little bit of experience, to within like 10, 15 minutes, create a make it data type, if that is something that you would need for your project. So that is also one of the things that ties into the fact that Postgres has all of these data types available for you and more if you need. If you start looking at Oracle specific data types like date time, like row ID, like XML type, those are available in Postgres as well as in Oracle, or in Oracle as well as in Postgres. If you look at JSON, JSON in Oracle is basically a varchar with a bunch of constraints around it. In Postgres, again, using the Postgres native extensibility system, there is native JSON and JSONB capabilities. It's got like 58 operators, functions, and related technology around JSON. If you use a JSON document in a Postgres database on the front end for the developer, it will just look like a JSON document. For a DBA though, it's just a relational table, meaning that in one single ANSI SQL statement, you can join relational tables to JSON documents. That is a very powerful technology to be available in a relational database, I guess. Spatial, yes, both databases have spatial. Spatial in Postgres is basically enveloped in a extension. It's called the PostGIS extension. And PostGIS arguably is the best geographical data extension there is in the world. Why? Geographical data systems are developed at universities. What do universities not have? Money. So what is it universities use? Open source. So for the development of a relational entity of spatial data, universities simply used Postgres because it was free, right? That is why PostGIS now is the most powerful and most used geographical data extension today. Now we get to indexes. B-tree hash expression, well, you can read all of this, the same between Oracle and Postgres. Reverse bitmap or block range indexes are similar. Cool thing is that a block range index basically is a smart scan. So what you can do, and what has been done already, is if you have an Exadata machine that is actually using some of that Exadata secret sauce, as one of my community colleagues used to call it, namely the Exadata smart scans, you can rebuild that using block range indexes in Postgres. If you take a very quick machine, even take your old Exadata hardware, put a Postgres database on it, you can actually start creating block or smart scans using block range indexes. K-nearest neighbor is one of these indexes that comes from geospatial. In Oracle, you can do it with some options. In Postgres, it is natively implemented using the PostGIS extension. GIST and GIN indexes, again, are the same between Oracle and Postgres. The interesting part for actually using the data that you've stored in the database are these SQL capabilities. So union, intersect, accept, inner joins, outer joins, you name it, they're the same between Oracle and Postgres. A cool difference is transactional DDL. Imagine you are creating a table, you're doing something, and you say, you know, I'm done with the table, you do a rollback, and not just the data is gone, but also the table is gone. That is one addition. What about if you start creating a new table, and every new connection that comes to the database can actually see that table until you commit it, and then it's available for the entire database. That is something an Oracle database can't do. This is something which is natively available in Postgres. We've done a little bit of a more deep dive. I had at some point Bryn Llewellyn, whom you might know as the former distinguished product manager for PL SQL and EDBR, edition-based redefinition, talking to Bruce Momjian about what is actually the difference between edition-based redefinition and transactional DDL. Okay, at that point, Oracle wins again because edition-based redefinition goes a step beyond transactional DDL, but it's also a whole bunch more complex, right? So just so you're aware. SQL extensions, dual, decode, row-nim, all these very trusted Oracle extensions, entities that are available in SQL, they're also available in Postgres in this sense. So you can actually do a select date from dual on a Postgres database. That's quite cool, especially if that is part of your application, right? That you don't have to rewrite it when you port it from Oracle to Postgres. In the area of high availability, point-in-time recovery, there was actually somebody who asked me, can I do a point-in-time recovery with Postgres? Well, let's see. We've got transaction logging or WOL logging. We're able to make a backup. Yes, let's assume we're able to do point-in-time recovery, and yes, we are. There are configuration files in Postgres that just allow you to say, you know, this is my database. I want to start it up, and I want to actually roll it forward to this specific point in time. No problem. Backup and recovery tools. In Oracle, we have RMAN. On the Postgres side, we have a very sexy marketing name called BART, Backup and Recovery Tool. Apart from that, there is a bunch more of backup tools. In fact, Postgres is so flexible and agile that if you say, you know, in my company, we've got, I don't know, some specific enterprise backup tool, chances are big that Postgres can be configured in such a way that it just works with whatever solution you already have. The flexibility of Postgres gives you the ability to mold Postgres. When we all started using Oracle, or in fact, many of these same generation software, you had to start making changes in your IT infrastructure to accommodate for this new application that you were starting to use and that you wanted to incorporate. Postgres actually is one of those tools that allows you to mold it a little bit so that it fits in, this is the way I want to run my IT environment, right? That's actually quite cool. Standby databases. So in Oracle, we've got Active Data Guard. Postgres comes with something that's called streaming replication. Streaming replication, native, out of the box, super stable, and actually does the same thing as Active Data Guard. So it gives you a standby database. That standby database is very easily read-only opened. It's super robust, and actually gives you that capability out of the box. Flashback query, flashback table, flashback database. Oh, unfortunately, not available in Postgres. I can't change it yet. Performance and scalability, connection pooling, CPU and I/O resource limits, well, similar. Columnar store. Columnar store in Oracle is part of the in-memory option. In Postgres, we have currently active the CStore foreign data wrapper. So CStore is a fork of Postgres that is actually a columnar store database. One of the cool developments that's now available in Postgres and that's being developed is a pluggable storage engine. And one of the things the community is actually working on is a columnar pluggable storage engine, which will give you the ability inside Postgres on a per table base to say, this table is just row oriented and this table is column oriented. That is coming. Pluggable, the infrastructure is there, but the storage engine itself is still being developed. If you look at in-memory databases, well, the name in Oracle kind of says it, right, in memory. Postgres doesn't have that. If you look at multi-master replication, we got Oracle Golden Gate, we got Quest Shareplex, there is HVR, there is some other players there. In Postgres, there is a bunch of both open source and proprietary solutions that give you the ability to do multi-master replication also in Postgres. Around security, so all the good things like LDAP, SSL, Radius, they're both available in Oracle and Postgres. If you look at connection encryption, password profiles, code wrapping, all of the things that make the database even more secure from an application perspective inside the database, they're similar between Oracle and Postgres. Extremely cool thing, I think myself, is database connection encryption. I've had this discussion with many DBAs and everybody says, you know, you can do this with Oracle as well. True, up to a point. What you can do in Oracle is say, my listener is secured, and as soon as there is nobody able to kind of interfere traffic that comes from the listener to the endpoint. Postgres goes one step further. In the core of Postgres, there is a configuration that is the PG-HBA configuration. In there, you can say, this specific user from this specific machine using this specific protocol, using this specific table or database inside Postgres can get access and the rest can't. You can go so far that you can even shut out people that are actually on the machine. So it goes 2 steps further than Oracle does there. And this is really, really robust. It is also one of the things that makes Postgres to be the most secure database on the planet. Might be quite interesting, especially as you start working with really sensitive data, right? On the other hand, if you look at something like Audit Vault, which is available in Oracle, that's not available in Postgres, unfortunately. If you start looking at database links, transaction log shipping, distributed transactions, those are similar between Oracle and Postgres. Session-based synchronous replication. So you have one session that lives on your system and you want to say, you know, the data that I'm going to change in this session needs to be synchronously replicated, meaning I only get a successful commit if it's also committed on at least one standby. You can do that in Postgres. That's not possible in Oracle. If you start looking at integration, SQL Server, Sybase, etc., that's possible with Oracle. Cool thing with Postgres is this thing called foreign data wrappers. Foreign data wrappers allow you to connect from a Postgres database to roughly 180 different individual data sources, ranging from the ones that are mentioned here up to Firebird DB. I never even knew that that existed, but that's the question that I had early on when I joined Postgres. And basically each and every data silo that you can think of in your organization, you can start connecting to Postgres using a foreign data wrapper. And if you even have a very specific requirement to connect it to an enterprise service bus, for instance, you can even start writing your own foreign data wrappers because that's just something that is supported, right? PL SQL, Oracle, yes. Postgres, compatible. Additional programming languages, and obviously Java, C, C++. And again, just like we saw with the data types, using the Postgres extensibility system. In Postgres, you've got a lot more programming languages. PL PG SQL, PL Java, again C, C++, PL Perl, PL Python. My personal favorite, PLR, which allows you to do all the cool data analysis stuff you would usually do with something like RStudio in a stored procedure inside your database, meaning you don't have to move data from the database first to a client, to RStudio, start working with it, doing difficult transformations, and then only get the benefit. You can now directly do it inside the database, there where the data already lives, giving you a lot more flexibility and giving you a lot more performance as well. Application development, and trust me, we're getting through this big pile of tables. But as I promised, there is a lot to compare, right? Entities, Java, JDBC, ODBC, .NET, they're the same. If you look at stored procedures, triggers, I can't read it all. You will get the slides afterward, I trust, Joy. And then you can read it for yourself. They're similar between Oracle and Postgres. And one of the cool things what we've done is we've added autonomous transactions to Postgres. So that is fairly new, but if you now have a PL SQL block that actually does that uses Pragma autonomous transaction, you can just run that on a Postgres database without having to rebuild the application. On big and unstructured data, again, spatial, I explained that a little bit. Oracle is good spatial, Postgres got a lot better spatial. Key value store, full text search, similar between both. XML storage compression, I write no. What I meant by this is Postgres is a project that is focused on the relational database. And that means a lot of the stuff that is done in Postgres has to do with databases. In the open source paradigm that's called horses for courses, we say, let the database do, or let each technology do what it's best in. Compression is something which is not necessarily something that belongs to a database, but belongs to the operating system. So let the operating system do compression. That being said, Postgres does a lot of compression inside itself already, something called toast compression, where each value that is written to a data file larger than a specific size, I think it's 5K, is already compressedly written to the database. And then obviously Hadoop, MongoDB, Cubes, yes, both available in Oracle and Postgres. And finally, management, bulk loader. In Oracle, we know SQL loader. Postgres has come to something that's called EDB loader that does more or less the same thing. In Oracle, the management console is called Oracle Enterprise Manager. In Postgres, it's called the Postgres Enterprise Manager. Again, what we saw before, point-in-time recovery, diagnostic tuning pack, SQL profiler, similar between the two. And if you look at automatic memory and storage management, yes, that's available in Oracle. In Postgres, again, we trust in the operating system. So memory and storage management is done by the operating system. And that kind of brings us to the end of that first comparison. Just a glance over the differences between Oracle and Postgres, just to put that here. A lot of these things that we know and trust on the Oracle side are also available in Postgres. And as you can see in the lower right-hand corner, Pragma autonomous transaction, DBMS redact, in Postgres 12, median, list egg, compound triggers are available in Postgres as well. And oh, this is one, one extra table. Oracle data types, comparison again between Oracle and Postgres. just for you to watch over which are the same, which are the differences here. That also means that on OCI level, and this is something that is added to Postgres, if you've got an application that is actually using OCI that wants to speak with the Postgres database, there is now an option to have that same application using an open client library, using libpq to actually write to a Postgres database the same way. So that means that if you have PL/SQL and you want to run it on an Oracle database, you can actually take the source script that you have running on your Oracle database and actually just run it on a Postgres database. That means because it's native compatibility, you don't have emulation, you don't have translation, it's actually native PL/SQL on Postgres. That is actually kind of cool. So that also means that that the Postgres database comes with all these cool built-in packages. So that means that if you're used to using these packages, you can just reuse them on Postgres as well. If you look at one of the bigger exceptions in the comparison here is Oracle Real Application Cluster. Oracle RAC is actually built using, and I think this is a cooler thing, an Oracle database is built on a shared everything infrastructure, meaning that an Oracle database is able to share disk space, it's able to share memory, it's actually even able to connect operating execution environments using Oracle Clusterware. This is something which is not possible in a Postgres database. A Postgres database is an entity in itself that actually is autonomous. That means it has its own execution environment, it has its own storage, and if you want to connect those, you would start using multi-master replication, as it's called, to connect two geographical applications together. So that is actually the way that it's done in the Postgres environment. Having seen all of this, the question is, okay, how do I get started? And when I started with Postgres, it's like, wow, this is really easy. It was back in 2017. I was joining Riga Dev Days, and for that I actually did the first presentation. I thought, you know, I set up Postgres, and I thought this is so easy that, you know, I spend a lot of time usually setting up databases. So I started talking to my colleagues, and they said, "Oh, well, you're really not really doing anything wrong, right?" Yeah, it's actually that easy, transparent to set up Postgres. So these are basically the steps you have to do. Set up your Yum repository and ensure that you do some changes there. So this took me 30 seconds. Network wasn't that fast. The Yum install took me 5 seconds because that was the install of the and just downloading Postgres. The database installing itself was another 15 seconds. Then I had to change the file, and I'm a slow typer, so that took me another 30 seconds. But after that, I actually had a Postgres database running. And that was kind of amazing because if you do this on Oracle, you spend easily half an hour installing an Oracle database from scratch. Within Postgres, it's literally a couple of minutes. Amazing.
Yeah, sorry to interrupt you.
Yeah.
We're getting a bit closer to the end of the first hour. So.
Yeah. This actually, thank you for that, Yuri. This was actually my final slide.
Oh, sorry. Yeah, just wrap up.
Yeah.
Okay.
So these are just a couple of links with some information. And you know, if you think Postgres, that sounds kind of interesting, I want to really try that. Go to postgresql.org, download Postgres, install it. If you want to really look at some of the Oracle stuff, there is a migration portal out there, migration.enterprisedb.com. The real message is have fun with Postgres, simply because you can. And that brings me to the end of what I had prepared this morning.